So we are given the equation of this surface, and we're pretending like we don't know what's going on. Now looking at this, I already have an idea of what it's supposed to be. This reminds me in the xy plane of the equation of a parabola, y equals x squared, right? You have a variable on one side that's not squared, and variables on the other side that are squared. So that's probably a paraboloid, and it's probably also concave up. So we're going to confirm this by graphing, following those steps on the screen. So first we're going to find the x-intercepts. So the x-intercepts are the points, if they exist, where the function touches the x-axis. So any point where the function, where the graph of the function touches the x-axis will be given when will be given by the values when z equals 0 and y equals 0. So when that happens, we'll have 0 equals x squared, which means x equals 0. So that means actually that my intercept is right here. This is also a y-intercept and a z-intercept, but we'll check if there are other y and z-intercepts. So once I on B, I try and find the y-intercepts. I'll make z equals 0, x equals 0, same thing, 361 y squared equals 0, which means y equals 0. So I get that same point. Then the z-intercept will work the same way. I'll have x equals 0. Oh, this is a, right? So I'm not changing actually. This is the y-intercept. This is the x-intercept. Then the z-intercept, like I said, comes from x being 0, y being 0, so that means also z equals 0. So these are the three intercepts of the function. It's the only point on the axis that the graph touches. The only point, right, in the singular is the origin. Now on item B, we're asking for the xy trace, the xz trace, and then the yz trace. So now we only make one variable equal to 0 at a time. So we're making, for the xy trace, we make z equals 0. So that means for z equals 0, we're making x squared plus 361 y squared equal to 0. This is a positive or non-negative number, and this is a non-negative number. If one of either x or y is not 0, this is going to be positive, and this is also going to be positive, or, right, making this greater than 0. So that means both x and y need to be 0. So that means the only trace, xy trace, is 1 point. Xy trace is a single point, 0, 0, 0. Okay? It's the single point. For the xz trace, we're going to find, we're going to use that y equal to 0. So our equation becomes z equal to x squared, and that's exactly what we were talking about before. That's a concave upward parabola. Okay? And that is the equation of the xz trace. The yz trace will be the exact same, just instead on the yz plane. The equation will be different. Remember that now x equals 0 on the yz plane. So looking at the equation again, z equal to 361 y squared. So the problem is going to be thinner than the previous one. So maybe you want to, on my sketch, I want to show that to you. It's going to be growing a little faster. And that finally means that you have, so look at it. You have putting all this information together. This at the origin. On xz, we have the wider part of the parabola. So I'm following this direction there. And on yz, that's what I should have written there, have the thinner parabola like that. So that means our paraboloid is thinner like that. So that is our picture. Maybe not great because of the traces, but if you want to be a little more accurate, you could see something like that. It's still not great. But we get the idea. We get the direction in which everything is clear. I think I could maybe reinforce the drawing. Erase a few loose ends there. I think that looks a little better. Point being that paraboloid needs to be thinner in the y direction. So I think that's better. This is the answer. It's A.